So we will talk about a bit about smart contract later, but let's move on to the concept of gas, right? So in Ethereum and in Bitcoin, we pay some gas fees, right? We are paying some amount of money in the form of as the form of tokens, and why do we pay it? Is so that our transaction can be added into the blockchain, right? Right. So first of all, let's talk about why do we require gas? If we do not use a gas fees concept, what is going to happen, right? So in case, let's suppose that we don't have any kind of a gas fee system in our blockchain network. So what will happen is that anyone can do any kind of a transaction on the blockchain, right? And it can also result into a DDoS attack, right? If anyone is allowed to do any number of transactions without any payment of it, if it's free, I can just go and do 100, 200, 500 transactions, and that is going to either lead to a DDoS attack or it can overload the system in itself. So that's one thing, right? And then by DDoS attack, I mean that there can be malicious transactions which can happen, which are obviously not going to be added into the network, but the system still has to process them, and that is going to take computation and a lot of resources, right? And then if we are not going to pay it, how are we incentivizing the system, the whole system? Who is going to pay to it, right? So these are the main reasons why we require a gas fees to be present in the blockchain network. So this is a very basic diagram where on the top left is the user. There is a gas limit setting, and where it is a algorithm through which the user can find what is the current gas price, that is, or the recommended gas price in the system, by which its transaction can be added into the system, right? Now that transaction happens, execution happen, and after the execution, the miners are going to process that transaction. So there are two functions. If the transaction has successfully accepted, the gas fees is deducted from the user's wallet, and if it has failed, then the gas fees is not deducted from the user's wallet. These are the two things that can happen, right? This is an example of how gas fees is calculated. We will come back to it later because it uses a concept of EIP-1559, which we will first see, and then we'll come to this. Okay. So what is gas? Gas is the fee required to successfully conduct a transaction or execute a contract on the Ethereum blockchain platform. Fees are paid in tiny fractions of the cryptocurrency Ether, denominations called Giga V, right? So even Giga V is 10 to the power minus 9 of it, right? So there are three denominations. One is Ether, one is Giga V, and then there is V, right? So one Ether is equal to 10 to the power minus 9 ETH. I'll say one ETH is equal to 10 to the power 9 Giga V, and one ETH is equal to 10 to the power 18 V, right? So Giga V is just in itself means 10 to the power 9. So that's how it's related. And gas is used to pay the validators for the resources needed to conduct the transactions. And the exact gas price of the gas is determined by the supply, demand, and network capacity at the time of the transaction. And the gas includes base, priority, max, and calculating fees. So that's the basic of what gas is, why we have to pay it. And it is calculated. It is, it's the recommended one is based on the demand and supply of the network. So basically, if the demand is very high, you are generally going to pay a higher fee. If the demand is low, you are going to pay a low fees in the network. So why do we have to pay a high fees in the network, and why do we have to pay a low fees, right? So when we are doing a transaction in the network, so let's say there are 1,000 people in the network which want to do a transaction, right? but the next block can only contain 100 of these transactions, right? So but everyone now would want that their transaction should happen as soon as possible. Okay, let's say 200 more transactions are generated after this block is created, then that makes as 1100 transactions in total, and out of these transactions, whoever is going to pay the highest fees is going to be selected by the validator. And why the highest fee paying are selected? Because then that is the maximum, so that the validator can incentivize itself in the maximum with the maximum tokens possible. So if I want to publish a transaction with a very low gas fees, it is very much likely that it is not going to be picked by the validator even for days, right? It can stay in the pool for that long. So that's why if the demand is very high, there is a lot of people doing transactions. Most of them are so it become necessary for people to pay more gas fees in the network, right? But this became a problem, right? Because now since the validators are chosen in a random way, the validators can also have a say that okay, you can I accept only the fees which are more than 0.05 ether. Okay, and I'm not going to do any kind of a transaction which is lesser than that, right? And that's a choice the validator have, right? It can choose which transaction it has to publish. There is no restriction on that. So that's how the validator can try to trick the users to pay them more fees, right? Because in the game of business, we do not want any setbacks, and we want to have real-time transactions to happen very fast. Right? So that's why a new proposal was made, which is EIP-1559, right? So this is an upgrade that happened on August 5, 2021 to change how Ethereum calculates and processes network transaction fees. The upgrade made Ethereum transactions more efficient by using a system of block-based base fees and sender-specified max fees rather than bidding on gas prices to more evenly incentivize miners in periods of high or low network congestion. Right. With EIP-1559, the base fee will increase and decrease by 12.5% after blocks are more than 50% full. For example, if a block is 100% full, the base fee increases by 12.5%. If it is 50% full, the base fee will be the same. If it is 0% full, the base fee would decrease by 12.5%. So what 12 point? Okay. So in EIP, what they are saying is that if a block, so in a block, what is the capacity of a block? The capacity of a block is defined by the amount of gas it can accumulate. Okay, so it is not defined by the number of transactions it can have, but it is decided by the amount of gas it can accumulate. Okay, so let's say there are 3 transactions. Transaction A take 1000 gas, transaction B takes 500, and another transaction C with 100 gas. Okay, if I say that there is a block which can accumulate only 1050 transactions, 1050 gas, it can only accumulate that much. So that block can either accumulate transaction 2 or transaction 2 and transaction 3 simultaneously, which are 500 and 100, which amounts to 600. So either those two can come together in that block, or a single transaction of transaction 1 can come in the block. Right. So that's how a block is filled. And how is it restricted? So if it is more than 50% full, that it has, okay, out of that 1000 gas, if a block has the maximum of 1000 block, if it has reached more than 500, then we'll say that okay, the demand has increased, we have a lot more transactions coming in, so let's increase the base price. So they increase by 12.5%. right? If it is 50% full, up 50% full exactly, there is no change, and up to 50%. And if it is 0%, then it is decreased by 12.5%. So this is how it generally happens, right? And the base fees is the minimum amount of a fees that the user has to pay. Okay, if the user does not pay that much amount of base fees, his transaction is not going to be introduced and added into the block by any validator. It is not, right? So if you put less base fees than what is currently present in the system, so until that base fees of that system decreases to your amount, only then will your transaction will be added into the system. Yes, Parv, I mean the amount of gas to be paid as fees. So coming to the I'll come back to the example of how this gas fees is paid, right? So this example is based on our EIP-1559 model, right? So example is that Shubham has to pay 1 ETH to Rahul, right? And this processes a gas limit of 21,000 units, right? So if 21,000 units of gas is required in case of a cryptocurrency transfer from one wallet to another. So this is a minimum, not even a minimum, this is the exact amount which is required. And if you go to MetaMask, if you do a transaction, you will, for every cryptocurrency transfer in Ethereum you are going to use, it will always going to pay 21,000 units of gas. And there is a base fee of 100 gigaV, and Shubham includes a tip of 10 gigaV, right? So what EIP-1559 says is that there is instead of paying everything to the validators, right? Because there has to be new tokens that have to be generated in the system for it to function. Now what that is always going to increase the supply, right, and decrease the value of these at 1 ETH. So instead of that, what we'll do is let's burn some of these tokens, right? And instead of inconsistent incentivization of these validators, let's have a way that they are also incentivized on adding one transaction, but it should be it should be based on something. It should not be improper. It should be something which is much more stable in the system, right? So that's why they increase a way that you have to pay a base fees which will be burned in the system, and then above it you can tip the validator to add your transaction in the network, right? So in this example, the base fee is 100 gigaV, a tip is of 10 gigaV. As you can see, the total fees that has to be paid, this is the total fees, which is 2 million, or I'll say 0.00231 ETH, right? So a total of 1.00231 ETH are subtracted from the Shubham's account, and Rahul will be credited with 1 ETH, while only 0.00021 will be received by the miner or by the validator and the other amount, which is 0.0021, it is ignited. By ignited we mean that it is burned. It is no more in the system. So what all transactions, so if we talk about this specific situation in the blockchain where the base fees is 100 gigaV, then all those transactions who have specified the base fee as 100 gigaV are going to be a part of it. They are eligible to be added by the validator into the block. Now only those, so now the validator can choose those transactions that are going to pay him the highest fees, right? So if I have 10 gigaV, if I have 30 gigaV, so 30 gigaV, if I provide a tip of 30 gigaV, that transaction is going to be chosen first over the other transaction which is only paying a tip of 10 gigaV, right? So now these this can happen. So this provides a stability in the system of where almost the amount of tokens that are burned, new tokens are also generated. So it will just not decrease the value of ETH that much, although it does decrease the value of ETH as the time goes by, because a lot more tokens are generated than which are burned. So that is how EIP-1559 works. Right. Now moving on to the, so if you have any questions related to the gas, you can just ask right away. Otherwise, we'll just move to the last segment of today's class. Moving on to the last slide of this day, which is on smart contracts. So we'll just okay, I think we have one. Moving on to the last slide, which is about the smart contracts. So as we have talked about in the EVM section, that Ethereum virtual machine is it's the core component that actually processes a smart contract, and that's a very powerful engine that is provided to Ethereum, which is not present in Bitcoin, right? And that's why the Ethereum became that much popular, that not only we can now use blockchain to just transfer some money over that network, now we can actually execute some amount of code or a business logic which is immutable. That's the power of smart contract, which is powered by the EVM, right? So a smart contract is a computer program that directly and automatically controls the transfer of digital assets between the parties under certain conditions, right? So it can not only it can be used to transfer digital assets, but it can also use to do any kind of computation over the network. Even if I want to just verify or add a list of valid contractors or valid people into a smart contract, I can do that. I can add, remove it. I can just create a simple smart contract which is just going to do publicly provide to the users who are list of valid auditors, and it can provide a way to add them or remove them, right? The benefit of smart contract is that the bytecode of that smart contract is available to everyone, and if the byte contract is present, then you can these are also publicly available smart contracts. So you have to make it verify. You have to provide the actual code that you have done, right? So by now that the people would know that okay, the functioning of your system or of your business, if you are doing it through that smart contract, now that smart contract is immutable. Now it is known to everyone how it is working. Now they can trust the system more, that okay, this is how they are working, this is how they are deciding, this is how they are operating. So now okay, if this is how they work, now I can actually trust this system, right? While in the case of Web 2, most of these applications are they are not public, they are behind the scenes, right? Just for Facebook, Instagram, what they are doing with it, how is it saving, how is it choosing what to show you, everything is not public, it is all private in these applications. So that's why smart contract have a very high role in the current blockchain network. And that's after the smart contract came, they changed the game of blockchain itself. After which there are a lot of blockchain that started coming up, which were the first few of them were EVM compatible. Then Solana came in, so Polkadot came in. So then other based on other virtual machine came in blockchains, right? So a smart contract just works in the same way as a traditional contract, while also automatically enforcing the contract, right? So now that you can by automatically enforcing is that you can provide a set of rules, you can provide functions in that smart contracts, which has a set of rules. So which has a set of rules which a traditional contract can have, while they are automatically enforced, because now they are public. If I call that function, those rules are going to be automatically enforced. That's how it is. Why it is said that okay, these contracts are automatically enforced if you have added them in the smart contract, right? So these smart contracts are programs that execute exactly as they are set up, coded or programmed by the creators. Just like a traditional contract is enforceable by law, smart contracts are enforceable by code. The Bitcoin network was the first to use some sort of smart contract by using them to transfer value from one person to another, right? But it's not, I think it's wrongly written, the Bitcoin network. It's the Ethereum network was first used. Bitcoin network does not support smart contracts yet. The smart contract involved employs basic conditions like checking if the amount of value to transfer is actually available in the sender account, right? So this is as this to invoke a smart contract, you have to pay two kind of fees, right? First fee is for the execution of that contract, and second fees is what you have to pay to execute that set of code. So we will talk more about in the future sessions about how it is done and how it works, right? So later the Ethereum platform emerged, which was considered more powerful precisely because the developers were going to make custom contracts in a Turing complete machine. On the left side, it's just the difference between how a traditional contract and a digital contract works. So you can take a look at it. In the traditional one, they have a paperwork done on a sheet of paper, which verifies who is going to be the owner. The same way, if I write that code in the smart contract, that who is the owner, if I invoke that function, if it changes the ownership, then in blockchain that is automatically verified. Right? So moving on, this was the last slide for the day. So this is it for this session. If you have any questions still remaining to ask, you can ask right now. Or even if you have, I'll say that, if you have written some of these terms and terminologies, you can just go and search it on the web. Ethereum.org is a very good source of initial learning of how a blockchain works. It will provide you information of proof of work, proof of stake, right? We have not discussed things in depth about what epochs are, what are nonces, transactional nonces are present, block nonces are there, right? What are timestamps, right? How the wallets are managed and how things are done, but we will make them a part. These are all a part of our future classes. We will just go in more in depth on all of these things. So thank you everyone. Thanks for joining.